Okay, for this one over here, which of the following functions is not continuous everywhere? I would try to visualize that, and I'm going to just try to visualize one at a time. And they're fairly easy to visualize because they're easy functions. For example, letter A, below the zero and equal to zero, it would be a parabola that opens downward like this over here with a vertex there, all right? Now, if it's to the right of zero, it's a parabola that opens upward like this over here. So clearly, this thing is continuous everywhere, all right? So let me go to the next one. The next one's going to be, there's two separate lines there. They both have a y-intercept of 1 when you're close to, when you're at 0, all right? So the first one is when you're below 0, that's less than or equal to 0. It has a slope of 2. So I'm going to say something like, let's see, slope at 2, something like this over here, all right? It's a line. And it includes this point over here, all right? So let me just think about that a second. I got 1. To the left of 0, it's that line, which has a positive slope. And to the left, it has a slope of -2, and it goes like this over here. So I'm going to say this one is also continuous everywhere. If you just look at it, I mean, bottom line, you're never lifting your pencil up to draw that. All right, let's go to the next one, which I'll put it down. It's going to be another visualization. And what do you got at when you're less than 0? Right, less than or equal to 0, it looks like just a line. It looks like this over here. And that line's going to intersect the y-axis at 1. All right, when you're below 0, it just looks like 1. That goes on forever, by the way. And then when you're to the right of 0, it looks like e to the x. And e to the x has a y-intercept at 1, so it looks like this over here. This is also an example of continuous function everywhere. All right, let's go to D. Hopefully D is going to say something. If not, I got choice E. So what's D going to be? Well, I got to look at it. And, to the left of 0, it's a sine function. And the sine function, and by the way, it hits 0, it looks like this over here. And it goes on forever. All right? So that goes on forever and ever and ever. Now, when you're to the right of 0, what happens? You got the cosine function, and what does that look like? This over here. So I'm putting an open circle there. This is discontinuous. Where's it discontinuous? Right over here. It actually jumps. All right, so D is the correct answer. Thank you.